Hello student, I am Arnab Das. Today we discuss about the new topic, that one is the binary symmetric channel. This is also an example for the discrete channel where two input symbols are present. One is the x0 and another one is the x1, and their two output symbols are present. One is the y0 and y1. Y1 is due to the region of x0 and x1, and it can be represented by the transition probability, which is due to the region of x0 and also due to the region of x1. If you consider for the y0 probability, that time this is due to the region of probability transition for p of y0 x0 and p of y0 x1. If we consider for y1 case, that time this is the transition probability for p of y1 x0 and p of y1 x1. So this is the typical figure for the binary information channel. If we recall our memory for the joint probability matrix properties, that time you can identify the value for the y0 probability and also the y1 probability, and they will be represented with that particular equation. For the p of y0 is this one, and p of y1 is represented in this form. So this is the binary channel, and these two are the equation for the probability for the y0 symbol and for the y1 symbol. If you represent into the form of PTM, that is the probability transition matrix, that time the output symbol probability will be represented in this matrix form. And how you can got it this one? If you this multiply this row with the column, that time you can able to see that this one is coming from this one. And here also, if you consider for equation 2, that is, if you use this equation, that time if this one is got it due to the reason of row and this one is the column. If you multiply these two, that time you can got it p of y1, that is the probability of y1. So when this information, binary information channel, will be named as the symmetric, that is the binary symmetric information channel, when it will be named. Condition is that p of y0 x0 should be equal to p of y1 x1. That is, for the output symbol y0, the transition probability will be due to the region of x0 should be equal to the at the y1 output symbol, the transition probability due to the x1 will be equal, and let this is the p of 1. Same way, the other two transition probability at the side of y0 and the side of y1, it should be equal to 1 minus of p. Basically, 1 minus of p is defined as the error probability, and p is defined the common transition probability for binary information channel. So there the figure can be modified. For the binary information channel, figure will be modified in this form, where p of y0 by of x0 will be defined as a p, because this one is equal to p. So you just put this value in this position, and there p of y0 by of x1, and this one y0 by x1, this can be represented as 1 minus of p. So ultimately you can got the binary information channel. And what will be the PTM, or the probability transition matrix, for the binary information channel? It would be defined as a p of x0 p1, and matrix will be P P 1 minus P in the row form and 1 minus P at the lower row. It will be 1 minus P and P on there. There an example is provided, and I think it will be easy for understand also, where probability is taken as a form of uh, 0.5 for the P of y0. This is P of y0 by of x0, and P of uh, y1 by of x1 is defined as a 0.5. So obviously 1 minus P also will become as a 0.5. So this is a typical example. You can able to understand the binary information channel if the direct probability is 0.5. Now there another one example also is given on here, where the three input symbols are present and they are x1, x2 and x3, and the three output symbol are present, y1, y2 and y3. So obviously y1 is the reason for the x1. By using this arrowhead you can also able to identify y1 is reason for the x1 input, x2 input and x3 one. So individual transition probability will be P of y1 x1, this is 0.8, P of y1 by of x2, it will be 0.6, and P of y1 x3 is defined as a 0.4 on there. So I think it is easy to understand also. Now the question is that you have to build the channel matrix. You have to build the channel matrix on there. How can you got this one? You just recall on there the probability properties, that is the joint probability properties, where you know that P of y2 or you can able to identify that this is P of the same thing is given on there, which is a missing on, in this case this is represented in here. So this one line, that is the P of y2 of x1, this one miss one which is not given on that, this is for the y2, it is calculated on here. This is defined as 1 minus 0.8 for first one. This is this one. Why this is? Because P of x1 is should be equal to 1. P of x2 is should be of 1. P of x3 also should be equal to 1. So here P of y2 by x1 is will be, there the two path is present. So this is 1 minus 0.8 will be defined the value of P of y2 by of x1. So that is 0.2 on there. So here if you consider for this path, this one is the missing on there. Okay, so how can you got this one? This is 1 minus 0.6, because there two path is present, there two path is present and one is given 0.6. So obviously another one is the 1 minus of 0.6, that means the 0.4, because the probability of x2 is the 1 on there. Okay, same way for the x3 you can able also identify the value for the P of y2 by of x3. How can you got this one? How can you got this one? Because summation of or the probability of x3 is total 1, so this path value will be what? 1 minus 0.5 minus 0.4, so it will be 0.1 on there. So check on there. So matrix form value you can be write down already. This is the y1 by of x1 channel matrix, the value is 0.8 is given to you, so you just put this value in this position, and you calculate. This is p of y2 by of x1 is 0.2, but if you check on there, the y3 by of x1 is not connected on there. Look that from here, from this position to this position, there no probability is required, transition probability is not required, because there no path or connection is present on there, so this is 0 on there. Okay, so on that way you can complete the total matrix. Now the another one example where it is defined a BSC, that means the binary symmetric channel, where two inputs are defined as a 0 and 1, two outputs are 0 and 1. So if you use the property for the binary symmetric, that time p of 0 0 and p of 1 1 should be equal, and due to the reason of this, p of 0 0 is 0.7, so obviously p of 1 1 also will be 0.7. If you apply this one, that time the matrix will be this one. Why this is 0.3? Because summation or probability of 0 should be 1, probability of 0 will be should be 1, so one path, if it is 0.7, 1.1 path should be 1 minus 0.7, that is 0.3. So you can record the matrix on there. Example 3 is that the missing term you should be identify on there. That means missing terms are x1 for the row, this is x1 position, and y2, that is the probability of y2 by x1 is missing on there, and probability of transition, probability of y1 x2, it is also missing here, this one term is missing. So how can you calculate this one? Probability of x1 is total 1 is the 1, so if you add the row on there, that time it will be equal to 1, so already 0.8 plus of 0.2 is equal to 1, so obviously missing term will be 0. Now if you consider for the summation of x2, that time this two row addition will be 0, so this is missing term will be 1 minus 0.6 minus of 0.2, that means 0.2 will be the missing one value, that is transition probability y1 by of x1 should be 0.2. You just follow the same rule in here also to get the p of y3 x3, that means 1 minus 0.2 minus of 0.3, that means 0.5 will be the value for the p of y3 x3. So in here this individual value is given to you, what will be on there, this is 0, this is 0.2 and 0.5. Why it is, I already discussed on there for the previous one page. So if you draw the corresponding channel or channel diagram, so here should be the three input is present, x1 x2 and x3, because for the question it is given that their matrix, this is the inputs are given on there, that is three inputs are present on there, and there are three outputs also present. So you initially dotted 3 at the input side, that is x1 x2 and x3, same way at the output side y1 y2 and y3, and which transition probability will be present, that one particular line you should draw on there, otherwise another one where the probability transition is 0, you're not required to draw the line. So if you do this one, that time here y1 and x1 from that particular matrix, you can know that this is 0.8, should the line you should be drawn there. Y1 and x2 it is present 0.2, and from x3 and x y2 y1 by x3, it is also present, so this is 0.2. Look that matrix 1 here, y1, if you consider this one, this is y1 x1 is 0.18, y1 x2 is 0.2, already calculate, and y1 x3 is 0.2. So you draw three line from three input symbol. One is from x2, one is from x2, and another one is x3. But if you consider for y2, that time there this value is equal to 0. So from x1 there no line will be present on there. Look that for the figure, from the x1 no line is present. Okay, so another two line you have to draw. For the transition probability, y2 due to the region of x2 will be 0.6, so you just apply 0.6, and this one. On this way you can draw the channel diagram, and from the matrix you can also draw the channel diagram if their missing parameter is present, so that time also you can able to identify what will be the transition probability. So thank you for today's class, and we again meet together for the new topic for the new class. Have a good day. Thank you.